I can't remember the scientist's name, but she was one of the most enthusiastic people that I've seen. So if we can have more of this enthusiasm, this excitement, it's going to generate a generation of kids wanting to go into science. So I'm going to keep my comments short in there, and I will yield back, and I'm excited to hear what you guys have to say.
Great, and I now recognize the chairman of the full committee for a statement, Mr. Smith.
Thank you, Madam Chairwoman. In August, millions of Americans turned their eyes to the sky to witness a rare event, a solar eclipse. The Great American Eclipse was a profound experience for anyone fortunate enough to be in the path of totality, and exciting even for those of us who witnessed a partial eclipse. An eclipse is a sight that has inspired previous generations, and one that I hope will inspire a whole new group of young people to study the universe and beyond. It was an 1878 American eclipse that inspired a young inventor named Thomas Edison. Edison took a trip to Wyoming to view the total eclipse and attempt an experiment to measure the sun's corona, or outer atmosphere. The experiment failed, but allegedly inspired him to think about the principles of light and transmission of power. The very next year, he invented the incandescent electric light bulb. Who knows what discoveries this year's eclipse will inspire, but we do know it has already generated an enthusiasm for astronomy, astrophysics, and astrobiology. Thanks to the good work of NASA, NSF, and their partners, that enthusiasm was converted into viewing parties, STEM education lessons, and citizen science that engage millions of Americans. We have the privilege today of hearing from a panel of witnesses who helped make the day a success for both science and education. I thank our witnesses and look forward to seeing their incredible photos and videos, learning what scientific discoveries may come from experiments conducted during the eclipse, and hearing what's next for solar science. It is human nature to seek out the unknown and to discover more about the universe around us. We have an extraordinary opportunity to turn enthusiasm for the Great American Eclipse into a renewal of American physics and astronomy that lasts far beyond the 2 minutes of totality. Thank you, Madam Chairwoman. Yield back.
Thank you, and I now recognize the chairman of the Space Subcommittee, Dr. Babin, for an opening statement.
Thank you very much, Madam Chairman. I want to start by thanking our colleagues and also our witnesses that have come forth with this very, very interesting hearing. Something that struck me about this eclipse is the level of excitement that it generated all across the United States. The eclipse was something that really brought us all together in our inspiration and awe. But I'd like to also add that NASA's web traffic during the eclipse skyrocketed. It peaked at 7 times higher than its previous record. The eclipse's online viewing audience compared with the audience for the Super Bowl. And even Netflix lost 10% of the day's viewership of the eclipse. And schools across the country incorporated the eclipse into their teaching programs, and there's no telling how the eclipse sparked the imagination of our school kids and captured their fascination, and thoroughly enjoyed myself showing and explaining to our school children in some parts of my district during that time, including my own grandchildren, the little cereal boxes that our chairwoman had just talked about that we had made. They're solar viewer projectors, I think is what their real name is. But it was one of those rare, wonderful events that was exciting to the scientific community as it was to the man on the street. It was an inspiration to our youth, and it brings to mind an interesting comparison. In a way, the 2017 solar eclipse was almost like a space station, a space mission that was brought into our own backyards. I'm very excited about the upcoming 2024 eclipse, which in my opinion could be even more impressive and awe-inspiring, not the least because the path of totality for this eclipse travels right across my home state of Texas. I want to thank you all for your testimony and looking forward to it. And I'll yield back, Madam Chair.
Thank you, and I will now introduce our witnesses. Our first witness today is Dr. James Ulvestad, Acting Assistant Director of the Directorate for Mathematical and Physical Sciences at the National Science Foundation. Prior to the NSF, he was Assistant Director of the National Radio Astronomy Observatory, where he oversaw the very large array and very long baseline array radio telescopes. He has also served in various capacities at the NASA Jet Propulsion Laboratory. He received his Bachelor of Arts degree in astronomy from the University of California at Los Angeles and his PhD in astronomy from the University of Maryland. Our second witness today is Dr. Thomas, I'm going to let you. Zurbuchen, Associate Administrator of the Science Mission Directorate at NASA. He previously served as a professor of space science and aerospace engineering at the University of Michigan. He has worked on several NASA science missions, including Ulysses, the Messenger spacecraft to Mercury, and the Advanced Composition Explorer. He earned both his Master's of Science degree and his PhD in physics from the University of Bern in Switzerland. Our third witness today is Dr. Heidi Hammel, Executive Vice President of the Association of Universities for Research in Astronomy, a group of 44 U.S. universities and institutions that operates world-class astronomical, I don't know my glasses, observatories, including Hubble, the National Optical Astronomy Observatory, the National Solar Observatory, and the Gemini Observatory. Since 2003, she has served as one of 6 interdisciplinary scientists advising NASA on the science development of the James Webb Space Telescope. Dr. Hammel received her undergraduate degree from MIT and her PhD in physics and astronomy from the University of Hawaii. Our fourth witness today is Dr. Matthew Penn, astronomer at the National Solar Observatory in Arizona. He is a principal investigator on the Citizens Continental Telescope Eclipse Experiment, or Citizen-CATE, and a telescope scientist for the McMath Pierce Solar Facility on Kitt Peak. Specifically, he works on the DKIST telescope project under construction in Hawaii, developing infrared science and instrumental requirements. He received his Bachelor's of Science degree in astronomy from Caltech, as well as a PhD in astronomy from the University of Hawaii. And our fifth witness today is Ms. Michelle Nichols-Yehling, Director of Public Observing at the Adler Planetarium in Chicago. While at Adler, she has developed exhibits, shows, and programs and events for Adler guests. She also leads the Adler's various telescope, observatory, and sky observing efforts. She earned her Bachelor's of Science degree in physics and astronomy from the University of Illinois at Urbana-Champaign and a Master's of Education degree in curriculum and instruction from National St. Louis University. And I now recognize Dr. Ulvestad for his statement and testimony.
Thank you, Chairwoman Comstock, Ranking Member Barra, Chairman Smith, Chairman Babin, members of the subcommittees. I'm James Ulvestad. I'm Acting Assistant Director for Mathematical and Physical Sciences Directorate at National Science Foundation. And thanks for the opportunity to testify here today. I want to focus my oral remarks on NSF's solar research efforts and the large-scale outreach associated with the eclipse. So as you've all said, August 21st was an exciting day for our citizens and scientists alike, as our nation was center stage for the 2017 total solar eclipse, the first in the continental US since 1979. So scientists and spectators from around the world, including members of Congress from these subcommittees, and you can see yourselves up there possibly, gathered across the country to witness this extraordinary event. The eclipse was a total solar eclipse, where direct sunlight was blocked for over 2 minutes while the moon covered the sun. It made its way from Oregon to South Carolina, illuminating a 70-mile wide path across 14 states. The rest of the continental US experienced some percentage of a partial solar eclipse during the eclipse's 90-minute traverse across the country. So the sun is the basis for life on Earth. Its magnetic fields and atmosphere, specifically its corona, fuel a space weather that affects Earth's power grids and communication systems. The sun's power is also a source of renewable energy for our advanced civilization. And the fundamental importance of the sun leads NSF to sponsor a broad array of research related to our local star. NSF-supported scientists track the development of sunspots, flares, and coronal mass ejections. They work to better understand how these phenomena are associated with the sun's magnetic field, which influences the energetic space weather events that can wreak havoc on our technology. So during the eclipse, the High Altitude Observatory of NSF's National Center for Atmospheric Research, in partnership with the Harvard-Smithsonian Center for Astrophysics, flew an airborne infrared spectrometer on board NCAR's Gulfstream 5 research aircraft. This instrument collected infrared data to probe the complex magnetic environment of the sun's corona. Of course, there aren't results yet. As science goes, there will be results coming out over the next year or two. So researchers in general continue to study the behavior of the sun to develop warnings of solar storms that may be coming toward Earth. So the Global Oscillations Network group of NSF's National Solar Observatory, a network of 6 solar monitoring telescopes sited worldwide, provides full-time monitoring of the sun and is a critical element of space weather forecasting models. So now let me move to the eclipse and some of the outreach efforts. And first I want to say here that any funding that the federal government put into this was leveraged by a factor of 1,000 by the Planetaria, the high school teachers, the college students, the random citizens and amateur astronomers who went out there and engaged with the public. So I really want to thank them for that. So one of the activities that Chairwoman Comstock already mentioned was the citizen science project Citizen Kate, the Continental America Telescope Eclipse, an experiment that included a network of 68 identical telescopes placed along the 2,500-mile path of totality, operated by citizen scientists, high school groups, and universities. So NSF Director Dr. Franz Cordova, who's shown on this slide, was pleased to be in Glendale, Wyoming, which I think had a 100 or 1,000-fold increase in population for one day, to experience the solar eclipse and participate firsthand in Citizen Kate outreach. You'll hear more about this from Dr. Matt Penn. NSF also funded the American Astronomical Society program called Solar Eclipse Across America. This included a mini grants program that funded 31 projects in 21 states. Now, as far as the future goes, by early 2020, NSF's Daniel K. Inouye Solar Telescope, the new centerpiece of the National Solar Observatory, will be complete on the summit of Haleakala on Maui, Hawaii. It will provide researchers an unprecedented close-up view of the solar corona without having to wait for a solar eclipse. The enhanced understanding of the sun and the origin of solar storms will undoubtedly contribute to better predictions of space weather in the future. So the solar eclipse was a great opportunity for scientific research and citizen engagement in an event that brought a sense of wonder and curiosity to scientists and citizens alike. The basic research conducted with DKIS, which you see here, will revolutionize our understanding of the sun in the future. We're looking forward to the next eclipse in 2024. There will also be an annular eclipse in 2023, so a six-month ahead rehearsal. And we're pleased to enjoy the support of the public in fulfilling our role. We thank the subcommittee members for their ongoing support of NSF in our efforts to serve the people of the United States.
Now recognize Dr. Zurbuchen.
Madam Chair, members of the subcommittee, as a head of NASA's Science Mission Directorate, I represent the thousands of volunteers, partners, and NASA employees who made the 2017 eclipse the biggest media event in modern history of NASA. I would like to describe NASA's experience with the eclipse, highlight some of the results of our science and STEM efforts, and discuss how important heliophysics is for NASA's mission. On Monday, August 21st, a total solar eclipse across the continental US occurred for the first time in almost a century. And I'll share with you my own vantage point, which was at 45,000 feet over the Pacific Ocean in an aircraft outfitted with science experiments to capture views before, during, and after the event. It was truly breathtaking. Watch.
Oh, wow.
Now, look.
Oh, my God.
Look. It's incredible.
Oh, my God.
Wow. Did you see the little beads just before, that's when we took off?
Oh, jeez, look at that.
Do you see them? God, look at this. See these streamers, these magnetic streamers. Do you see the lines?
Two lines.
Oh, wow. Let's look at, it's absolutely amazing. Look at this background.
Look how dark.
We're in the middle of a dark cloud. Wow, we see the shine up there. So it's popping back out.
Oh, there it comes. Wow.
See the ring around it?
Yeah.
That's the silver ring. So cool.
Unbelievable.
I've done research on this for 25 years. I've never seen it, you know? So I was excited, you may be able to tell. I was so excited that I mixed up the colors. It's called the diamond ring, not the silver ring, if you want to quote that. So, well, anyway, our NASA team and scientists around the country have been planning for this eclipse for many years. And with me at the hearing is Dr. Alex Young, right behind me. Our project manager, who has been a champion for the eclipse and working with a broad NASA team for over 3 years. The team focused on key priorities: safety, science and citizen science, education, and public engagement. To accomplish these priorities, we knew we couldn't do it alone. The entire agency rallied, and each of our 10 centers led major functions and events, partnering really broadly. The eclipse was the biggest science outreach event in modern NASA history. Working with our partners, we engaged with citizens across 14 states, nearly 7,000 libraries, 200 museums, Planetarium and Science Center, 40 Challenger Centers, and 20 national parks, zoos, and even baseball stadiums. More than 50 million unique viewers watched the TV broadcast across multiple NASA and social media platforms, and we had 90 million page views of NASA website on Eclipse Day alone. These numbers exceed previous records by many times over. I talked to many people after the eclipse, and it was really clear that not only professionals were deeply moved by it, but amateurs alike. This is truly moving. That's what NASA science does for us every day. Showing now our views of the solar eclipse from various NASA assets. 11 of them were focused on this unique event, as well as 3 aircraft. In fact, when looking at the eclipse, I could not help myself, just like the congressman, thinking of the Parker Solar Probe launching next year, which will travel closer to the sun than any time we've been there before, really making these unique observations of the extended corona and revolutionizing our understanding of the sun, which is really the Rosetta Stone of understanding of all stars in the universe. Additionally, NASA solicited experiments to take advantage of the unique opportunities provided by the eclipse to do science. 11 grantees were selected, 3 of which are studying the ionosphere, measuring how the sun's energy affects this region, this charged region of the outer atmosphere. ICON and COLD will continue to improve after the launching later on our understanding and predictive capability for what is happening to that region and the edge of space. We also want to stress citizen science, and I'm going to let Matt talk about this. It's really valuable to have science done, valuable science done by citizens, not just professionals, and there's true value with this, not just here, but elsewhere. With safety a top priority, we published protocols on our websites and partnered with the American Astronomical Society, NSF, and others to spread the word about eye safety. This proved critical when it was discovered that uncertified solar glasses were making it into the markets. We owe a debt of gratitude to our partners that helped us identify and communicate which glasses were safe. And in the end, NASA, Google, and the Moore Foundation distributed over 4.3 million glasses. In closing, let me talk about heliophysics, or solar and space physics, as others refer to it, that really protects and improves life on Earth. This total solar eclipse provided a unique opportunity of seeing the source of space weather with our naked eye, the atmosphere of our magnetic star. This corona impacts the Earth through the solar wind, explosions on the sun, flares, and energetic particles affecting our space assets and our technological infrastructure. And so we want to really make these improvements better for operational use for NOAA and the DoD. So I, too, suggest that we start making plans for the next solar eclipse in the U.S. on April 8th, 2024. It's going to be another great opportunity for all of us to learn about the solar system we live in, and I really suggest you get started with these hotel reservations. They got really expensive for those who were latecomers. Thank you so much.
Thank you. And I now recognize Dr. Hammel.
Madam Chair and members, thank you for the opportunity to testify about the total solar eclipse. On August 21st, 2017, millions of Americans, including me, witnessed the total solar eclipse, watching in wonder as our star disappeared from the sky. At the same time, scientists scrambled to collect as much data as possible about the sun's faint corona. The sun's corona is the source of solar storms. The term space weather refers to the effects of these storms on the Earth and other planets in our solar system. We live inside the atmosphere of an active star. In 1859, a monster solar storm, the Carrington event, stunned the world. Telegraph systems worldwide went haywire, emitting sparks that not only shocked the telegraph operators, but actually set telegraph paper on fire. It's sobering to imagine the catastrophic social and economic disruption of a Carrington-like storm on today's infrastructure, including GPS satellites, electricity grids, and communication satellites. And that is why understanding the sun and space weather are critical national imperatives. Eclipses offer one of the best opportunities to study the sun's active corona, but eclipses are rare. To study the corona without an eclipse, the National Solar Observatory, or NSO, is building the Daniel K. Inouye Solar Telescope, DKIST for the NSF. When completed in 2020, DKIST will be the world's most powerful solar telescope. Its 4-meter mirror will yield exquisite spectropolarimetric observations of the sun's corona and magnetic field. But let me return to the 2017 total solar eclipse, because it too was a unique opportunity to advance solar science and public engagement. NSO began preparing more than 5 years ago, focusing their efforts on science and safety. Claire Raftery, who is here with us today, and her team developed a social media campaign with a variety of content, including monthly webcasts that focus both on science and on educational engagement. And on Eclipse Day, NSO participated in 2 major solar outreach events. The first that you heard about was in Glendo, Wyoming. It culminated years of effort to prepare this tiny community of 200 people for this event. And the local sheriff's office estimated that 185,000 people descended on tiny Glendo, Wyoming, including, as you saw, the director of NSF, Dr. Franz Cordova. The second event in Salem, Oregon, focused on high school students. NSO, in partnership with other groups, trained a dozen students, all of whom are minorities that are underrepresented in the STEM fields, to be ambassadors for science. And on Eclipse Day, the students led the programs for the community. Looking to the future, as you heard, another total solar eclipse will sweep the country from Texas to Maine, and we are already preparing. We plan to engage with students in underrepresented demographic groups well in advance of the 2024 eclipse to prepare a new set of students to be community leaders and science ambassadors. And finally, my colleague here, Matt Penn, developed an ambitious eclipse program to combine public engagement with science. And I'd like to share a video about several young people in Dr. Penn's Citizen Kate program.
Edwin and Alexis Cochran are from a Native American reservation school in northern Montana. They took a road trip with their science teacher, Janet Jorgensen, to watch and study the eclipse.
It's just an amazing opportunity for the kids because this is real life science and it helps them be exposed to what kind of opportunities there might be in the future.
These students are one of 68 teams nationwide who participated in an amateur science experiment called Citizen Kate.
We're trying to get pictures of the solar eclipse so we can study the corona.
When the moment finally arrived, darkness descended on the town of JM, and the sight they'd been waiting for revealed itself. A total solar eclipse.
Yeah, it's taking pictures.
Before they knew it, it was over.
Right here. Yeah, we got a few pictures.
Oh my gosh, it's so pretty.
But for these kids from a remote Native American reservation, 2 minutes and 27 seconds will stay with them for a lifetime.
It was just something you don't forget, I guess. Just really pretty.
This eclipse changed their lives, and their Citizen Kate observations may improve our lives. These young people helped us gather the largest volume of science-quality eclipse data ever recorded. And I will now turn the microphone over to Dr. Penn to describe his program. On behalf of AURA and NSO, I appreciate your attention and be happy to answer any questions. Thank you.
Thank you. And now recognize Dr. Penn.
Madam Chair and members of the subcommittees, thank you for the invitation to speak to you about the Citizen Kate experiment. While Reba Doucette was crying tears of joy in Wyoming, Jack Erickson and his students from Cienega High School in Vail, Arizona, were close to tears, but for a completely different reason. If I could have my first slide. It was raining at their site in Pawnee City, Nebraska. Jack and his students were really eager to collect data. They'd practiced for months, and along the way, they had spoken with many newspaper and radio and TV reporters about the program. This media coverage followed many of our Kate teams across the nation. Local TV affiliates would find their Kate students from our 27 university and 22 high school partners and do stories on them. And these students would get recognized not for scoring a touchdown in a football game, but for doing a STEM project and observing the sun. My colleagues at NASA do an excellent job of observing the solar corona, but even their advanced instrumentation has a gap in our understanding. If I can have the next slide. A total solar eclipse opens up a window that allows us to study the inner corona. And the Citizen Kate experiment was designed to take advantage of that opportunity. You can see in the flashing rectangle, the Citizen Kate data fills the gap that we currently have in our understanding of the corona. Specifically, we're trying to measure the solar wind above the north and the south poles of the sun as it moves through thin magnetic structures that we call polar plumes. Now, just like sitting across the table from your daughter and watching her drink a milkshake through a transparent straw, you can measure the velocity of the milkshake by tracking features. We can use the Kate data to track features in the fast solar wind and measure the velocity of the solar wind that way. But unlike a milkshake, the fast solar wind has important implications for space weather, and therefore it's really critical that we understand it. So on the day of the eclipse, the Kate teams had enormous success. 62 of our 68 sites collected images of the corona. And today I'm happy to be joined by Miles McKay from the Space Telescope Science Institute. On the day of the eclipse, Miles returned to his alma mater at South Carolina State University and took data on the 50-yard line with a Kate instrument in a stadium filled with 5,000 cheering fans. We can see in a third slide that the skies cleared for Jack Erickson and his team. They were able to capture images with their telescope. On the left, you can see the corona that's been filtered slightly to show it as you might see with your eye. And then on the right, we see a more highly enhanced version of that image that brings out details that you can't see with your eye. Each of the Kate images shows the solar atmosphere across a region that's more than 1 million miles across on each side. And so from any one location where you just have 2 minutes to view the corona, you don't see a lot of changes during that short period of time. But the Kate data set, when it's combined, allows us to see changes across 93 minutes of time. So in the next slide, I've put together a very rough-cut movie of the Kate data set. We collected over 45,000 images of the corona on that day, but in the 4 weeks, I've only been able to process about 300 of them to show you here today. If you imagine that the moon is a clock face, at about the 7 o'clock position, you can see a system of outflows moving away from the sun. These are traveling at about 20,000 miles per hour. It's pretty slow for the solar wind. And then if you look closely at 5 o'clock, you can see a quicker outflow. This is, we think, a signature of the fast solar wind in the south pole of the sun. And that's traveling at something like 200,000 miles per hour, or perhaps faster. So even with just 1% of the Kate data analyzed so far, we're getting a new view of the solar corona that we haven't seen before. A lot of science will follow. I'd like to close by saying that a total solar eclipse is both an uplifting and a humbling experience at the same time. It's uplifting because it teaches us that we're smart enough to predict when these will occur. In my next slide, we can see, as my colleagues have mentioned, that the next eclipse visible across the country, across the United States, will occur on April 8th, 2024. But if we go further and try to figure out when is the next solar eclipse, total solar eclipse, visible from Dallas, Texas, we can predict that it will occur at 1:57 p.m. on Saturday, June 30th, in the year 2345. So mark your calendars, please. A total solar eclipse is also a humbling experience because it teaches us that we have no control over the huge planetary bodies that cause eclipses. It reminds us that we're just little people sitting on a big rock watching the show. It doesn't matter what your nationality is or what your age or your gender. Total solar eclipse is a really moving and human experience. So I'm looking forward to enjoying the next experiencing the next eclipse with all of you in April of 2024. And I'm looking forward to answering any questions that you might have as well.
And now we'll hear from Ms. Nichols-Yehling.
Madam Chairwoman and members of the subcommittees, thank you for this opportunity to testify. On August 21st, 2017, millions of people across the United States gathered. Friends, families, and strangers gathered by the hundreds, thousands, or tens of thousands in public spaces. They gathered in small groups or they found places to be alone. No matter the size of the group, the goal was the same: look up at the sky at an astronomical spectacle that hadn't been seen to this degree in our country for several decades, a solar eclipse. Coordination and planning of efforts for public engagement around the eclipse started several years ago. Organizations such as the American Astronomical Society and the Astronomical Society of the Pacific helped institutions and groups talk to each other to see where efforts could be shared. The American Astronomical Society and NASA served as clearinghouses of reliable scientific content to help the media, the public, and educators engage with the eclipse phenomenon. Universities such as Southern Illinois University at Carbondale and the University of Missouri in Columbia planned extensive public opportunities at many audience engagement levels. Institutions such as the Adler Planetarium in Chicago organized events for those who could not travel to the path of totality, but who still wanted to enjoy the sight of the partial eclipse. These were massive efforts that reached millions of people across the country. The Adler Planetarium started planning for this eclipse 3 years ago. We had several goals for our programs: increase the capacity of organizations around the Chicago area to host their own eclipse observing events, make residents of Chicago, the surrounding suburbs, and those in the region aware of what was happening and empower them with the skills and tools to observe the eclipse themselves, serve as a trusted source of information for the public and the media, provide eclipse resources for those who might not otherwise have access to them, reach traditionally underserved audiences, engage a variety of communities and get them interested in our universe, even if they had not been interested previously, and bring Chicago together because this was Chicago's eclipse to share. Our events were free and open to everyone. In addition to our programs in Chicago and in the surrounding suburbs, we brought our Galaxy Ride outreach program to over 2,300 people in several rural communities in Southern Illinois. We were also honored to be asked by Southern Illinois University to assist them with planning and facilitating several of their eclipse events that garnered national and international attention. And what were the results of these efforts? We distributed free of charge over 250,000 safe eclipse viewing glasses, including 10,000 given to schools to help students and teachers in the Chicago area watch the eclipse during the school day. The Chicago Public Library System and libraries throughout the region held eclipse viewing activities at dozens of library branches. Chicago Park District parks held eclipse viewing events. Our partners, such as the Chicago Botanic Garden, the Morton Arboretum, Naper Settlement, and WonderWorks Children's Museum, held viewing opportunities that welcomed thousands more participants. We empowered people who did not have solar viewing glasses to find safe and easy ways to view the eclipse via other means. The Eclipse Fest block party held at the Adler Planetarium attracted 60,000 people, which is 10 times the highest number we ever previously recorded for a sky observing event, and 10% of our annual attendance. The audience at that event was a cross-section of the diverse population of Chicago, including participants who had never interacted with the Adler Planetarium previously. We estimate the number of people directly impacted by all of our activities to be over 500,000. The next logical step to ask is, what's next? How do we leverage the momentum and excitement from this eclipse to carry us forward? This kind of effort is what out-of-school time institutions like the Adler Planetarium already do. The Adler Planetarium exists to help people become better connected with the universe. The public interest in the eclipse allowed us to scale our efforts upward to welcome more people. Illinois responded to us with an enthusiasm that was staggering. In addition to the collective inspiration provided by the eclipse, the Adler Planetarium hopes this incredible experience will also lead to, 1, financial and programmatic support for out-of-school time institutions to continue providing science activities to the public. 2, support for institutions and organizations to communicate with each other and jointly plan and sustain small and large science programs that have a variety of impacts. And 3, support for institutions to bring high-quality science and engaging science activities at low or no cost to underserved populations in urban, suburban, and rural locations. We hold fast to our core belief that making science welcoming, engaging, and accessible to all helps strengthen communities socially, culturally, and economically. After all, we share a sky above our heads, and everyone deserves the opportunity to engage with it. Thank you.
Thank you. And I now recognize myself for questions, for a 5-minute round. First of all, I just have to thank all of you for just this your role in what was just an incredible sort of universal experience that we all had. I loved watching the plane, Dr. Zurbuchen. That was, while my husband was with his cereal box, I really enjoyed having that bird's eye view. And it just was fascinating how, all of the communication beforehand to get everyone participating, to get the glasses, to do the cereal boxes, to have those large group events. I know in my district we had the Udvar Hazy Center, so we were very, and there was, my daughter lived near it. I was trying to tell her to get over there, and said the backup was, the traffic was incredible, so it was worse than the normal traffic that we might have. But I take that as a great sign of the engagement. So how do we now capture this in terms of directing this into STEM science? Because it was such a wonderful thing that you made it a real teaching moment. And how, going forward, can we get people more engaged in these fields and in STEM careers?
At NASA, we're committed to continuing the discussion and continuing the engagement about science of various types. We have really made a focus on telling the story, whether it's the discovery of planets elsewhere, whether it's about science of the sun, the earth, or everything in between. Really want to focus on that. Our STEM activities are through a series of collaborations out of the Science Mission Directorate, are supporting activities across the country in a variety of centers that are focused on both population, certain groups, but also on schools and museums to carry the message forward. We do so in partnerships with so many, such as the NSF or organizations that are represented here.
Yeah, and that was great. I really appreciate the comments on the children from the Indian reservation and how you're engaging them, and the diversity of folks that you were able to engage in this. I did want to recognize, since I have three of my students, I guess two of my students from my district who were active in doing this also. They were also two young women who were active in my Young Women's Leadership Program, where we tried to focus a lot on science, and thanks to we have Kendall and Reagan here, and then Kendall's mom, Jean Marie, so thank you for bringing them here. But maybe address a little bit about how you were able to engage everybody in that. And so how can we make, because this is a particular interest of mine, we had the Inspire Women Act that passed earlier this year. We're trying to get more women engaged in these fields. So maybe to our female witnesses, how we might do a little bit more of that.
Thank you. We're fortunate in that the universe has granted us a second go-round on this eclipse. And so the lessons that we learned from this eclipse about engaging the young people as being the ambassadors themselves to their communities is a fabulous way to engage young people in science and also into these leadership roles. And that's what will keep the young women and other people engaged in this kind of activity. So we're going to continue the kinds of programs that we started and try to, I hope we can try to expand those things as well. As you know from your experience, having the young people engaged, involved, and being the leaders themselves is a great way to capture them intellectually and emotionally.
One of our projects that the Adler Planetarium had was to give telescopes to some libraries and teach teens, young people at those libraries, how to use those telescopes. One of our goals is increasing the capacity of communities to provide their own observing opportunities. And so this was a great test of that, but in the future we hope to do more of it and also work with other partners, other museums, and folks, especially those we haven't worked with before, because this gave us an opportunity to reach other audiences. So reaching teens, reaching young folks, reaching other partners will be important to us, especially going into 2024.
Thank you. And thank all of you again. It really was an incredible project. I mean, all the work that you did, and we can't thank you enough. And I think we've harnessed a lot of that enthusiasm going forward for STEM. Thanks. And I now recognize Mr. Lipinski for 5 minutes.
Thank you. I hate to admit it, but unfortunately, I was not in the country the day of the eclipse, and I had a neighbor who, when he was telling me his plans about driving down from Chicago to close to St. Louis, and they were going to head all waiting for the morning, the weather forecast. They knew where they could go, where they could see it, and then hearing when he came back, and it was just something raised that excitement. And I remember from my own childhood, and it wasn't even anything like this, a total eclipse. I remember that. So it's a great opportunity, and it's especially great to know that it's not too long. We're going to have that opportunity again. So I wanted to sort of ask Ms. Nichols-Yehling about ways that you're going to use this, the planetarium, Adler Planetarium, is going to sort of try to use this to leverage interest in other of your outreach activities and longer-term public engagement in science, because you capture a lot of attention here, a lot of people's interest, and how do you sort of keep that going and also make sure people are aware of and draw people into other opportunities and other things that they can learn.
Exactly. This is basically what the Adler Planetarium does, and what we're really proud to do. The goal in the future, we want to not only reach people broadly, but we want to reach them in depth. And so we have several programs, especially those in our teen programs area, that really try to hook teens, but get them involved in real science. And that's one of the goals, is not just have people come out and enjoy the eclipse for one day. Give them other opportunities to come back to the planetarium and also explore other resources in their community to be able to go in more depth. And so one example is our high altitude ballooning program called Far Horizons. And so we have ways for kids to be involved in that, taking real science data, and have teens involved in potentially recovering pieces of meteorites from the floors of Lake Michigan. And so these are ways that we can really reach people, not just broadly, but try to really focus on the fact that science is best engaged when it's real.
Thank you. Anyone else on anything they're working on in that regard?
If I could just interrupt, we designed the funding for the Kate instrumentation so that the groups keep their telescopes the day after the eclipse. And so now we have, it's a small network, but a network of 68 groups that have their telescopes. And we have a working group that's looking at following up with nighttime projects. So the students who were really excited by the eclipse and are now really excited as well about STEM can continue observing with their Kate instrumentation.
Very good. Anyone else have anything to add? So what have we, anything that we've learned, you expect to learn, getting more sort of beyond the public engagement, about the, potentially about solar storms, threat of space weather? What are the expectations from the data that was collected from the eclipse?
So one of the most important elements, there's many, but one of the most important elements for NASA is that we were able, using this unique view, to test space weather models. So what we actually did is we tested models that were supported both by NSF and NASA, and we ran them on the fast computers, the fastest computers at NASA with, days to spare, and we're making predictions that are now tested and analyzed. And so it really became a benchmark type of test of these models that are so critical for space weather applications.
Thank you.
Yeah, if I could add to that, we used our Stampede 2 supercomputer for one of those activities that Dr. Zurbuchen mentioned, but also our network of solar telescopes around the world. We use that to help make predictions, and those are used operationally by NOAA and the Air Force for space weather prediction. So this gave us a chance to test the models that we're using from those observing telescopes and see if what they predicted was close to the truth or not. And that will enable us then to refine the models and do better in the future.
Very good, thank you. My time is up. I'll yield back.
Yes, sir. Now recognize myself. I'm Brian Babin from the state of Texas, and I'm sitting in for our subcommittee chairman, Mr. Comstock. I'd like to ask you, Dr. Zurbuchen, NASA is launching the Parker Solar Probe next year to dive into the corona closer than we've ever been to the sun before. What technological advancements will allow that to work, and what do we hope to learn?
So this is one of those missions that the community wanted to do since the 60s, when it was clear that there's a solar wind, and we were trying to figure out how it arose, right? It's now clear that that solar wind and its storms are really affecting our technological society. And so the technologies that are enabling the solar probe are really an advanced heat shield, first of all. Kind of that this thing gets really hot at the front end. In the back, you could easily sit. It's room temperature. I mean, so in the middle is high-tech heat shield. So that's technology number one. The second one is high-temperature solar panels. So if you took a regular solar panel to make solar energy, out there from here, it would, of course, not work because it gets too hot and the panel's short. So the panels that were developed for that particular mission were panels that can sustain the temperature, so be down there at close solar distance and work. So those are the enabling technologies, is certainly the ones that stand out in my mind. What we hope to get from it is really measurements that are focused on answering the pivotal question here, which is how does the sun accelerate the solar wind? We actually don't really know the extent, what heats the extended corona. Understanding that underlying physics not only will tell us about space weather, but about magnetic stars in general, because we know that these effects are everywhere. So this is a pivotal measurement we wanted to do for a long time. It's finally in reach.
Yeah, thank you. Very fascinating. And then Dr. Hammel, I'm very interested in the Carrington event, which I've read about, and you mentioned, I think it was you that mentioned it earlier. How likely do you think another catastrophic event like this will happen in the next, say, decade? Do we have any good predictive models for this? And then what are we currently doing? I think one big topic today is our infrastructure, our electric grid, whether it be man-made or some natural disastrous event like this. If you can answer some of those questions and elaborate, I would appreciate it.
Sure. As you heard from Dr. Zurbuchen, one of the activities that took place during this total solar eclipse was exercising our models. And it's our models that we rely on to determine whether or not an event like the Carrington event is likely to happen in the future. Yesterday, when we were preparing for this, we had some discussions about how likely is it, because we are curious too. And there have been some studies that have predicted that the probability of something like this happening is something like 10% per decade, of order. Not everybody agrees with that. That's just one of the models. But when you do the math and you think about when the Carrington event took place and where we are now, how many decades is that? 10% probability. We're pretty close to maybe having another one. And in fact, there have been, in recent months, some very large-scale solar flares that have taken place. Fortunately, they have not been directed at the Earth. And so we have escaped for now. There are, though, of course, on record, there's evidence that solar storms have affected things like airplane navigation systems, other kinds of lower-level scale effects. So it's real. It's going to happen sooner or later. So it's important that we are prepared for that. So what are we doing to prepare for that? A lot of people are thinking about that. Every year there's meetings of people that get together that include a lot of people who are interested in trying to mitigate, prepare, how to set up our infrastructure so that it is more robust, how to prepare our satellites so that if we know an event is going to happen, what can we do to power them down so they are not quite as severely damaged. And I know that there are many groups in the government who are working collaboratively together, not only our NASA and NSF representatives, but NOAA, FEMA, the Air Force. All of these groups have been talking actively about this. So it's a subject that is on people's minds. Do any of my colleagues want to add?
Yeah, I'd like to hear if anyone else has to.
I'll just add to the last point Heidi was making, which is for the last 3 years under the National Science and Technology Council, there's been a group called the Space Weather Operations Research and Mitigation Task Force, and they produced the National Space Weather Plan back in Space Weather Action Plan back in late 2015, and that involves, as Dr. Hammel said, NASA and NSF, but also FEMA is involved, Department of Energy. And so understanding how to predict solar storms and then understanding, okay, what is your response? How do the public utilities respond? And given a certain probability of a solar storm of a certain magnitude, what should they do? That's the kind of question that this interagency task force is wrestling with. One of the things that we've been doing recently is sort of working on establishing benchmarks for the level of solar activity that would cause us to recommend certain actions as a government. So I think that's ongoing. It's good to see a lot of different agencies working together. In the course of my normal daily life, I wouldn't interact with FEMA, so I think it's really good that we have that opportunity through this task force.
Thank you very much. My time has expired. But I want to say that I've been very active with FEMA here lately, too, because we had Hurricane Harvey down there. And appreciate your testimony. Now I'd like to recognize Ms. Bonamici.
Thank you very much, Mr. Chairman. Thank you to all of our witnesses. I'm from Oregon, so this was a very big deal in our state. The estimates were about 1 million people came into the state. We only have 4 million people living in Oregon, so it was significant, really, really important to our state. And really, it was awe-inspiring. We had astronomers and hobbyists and families and from all over the world actually traveling to my home state. OMSI, our Oregon Museum of Science and Industry, hosted a big event. Oregon State University in Corvallis had thousands of people for a viewing. They hosted exhibits, educational lectures. The university also had research projects that they initiated on the coast. A team of students from Lynn Benton Community College, for example, and OSU launched a balloon from the research vessel, the Pacific Storm, to capture live video of the eclipse. This balloon investigated the high altitude temperature and pressure variations, so that was exciting. The Ocean Observatory's initiative used in-water instruments to study how oceanic zooplanktons responded to the darkness caused by the eclipse an hour before the sky went dark. They started their nighttime feeding procedure, and scientists found actually that the ocean temperature barely moved even at totality. Really, really amazing experience. From what I personally felt, and I was at 99% just in my own neighborhood, the temperature dropped significantly, and that was the first thing everybody could feel, a significant drop in the temperature. And as the sky began to turn dark, we saw the wavy lines. It was a really, really amazing, awe-inspiring experience. I wanted to ask you, Dr. Penn, about Citizen Kate, because I saw how many sites you had across the state of Oregon, and what a great way to really capture so much as the eclipse moved across the country. Can you talk about, and I read a little bit and heard a little bit about your funding challenges along the way. Can you talk about the importance of the federal funding from NASA and NSF? And I know that was a big part, but as we set budget priorities here, it's really helpful to have yet another example of where federal funding made a difference.
Yes, so we started out in 2016 by getting a grant from NASA to do some student training. So Miles McKay was one of the students. We packed up a bunch of students with telescopes and sent them to Indonesia to get on-the-job training during the 2016 eclipse. And so then when they returned, we had some summer programs where they did some research with their data. But most importantly, they ran the workshops, the training workshops for 2017 volunteers across the country. So that was really critical. It not only took the burden off of me to try to train 68 teams, they spread out and did the training, but empowered them to learn about solar physics and to have the experience of the eclipse to start with. And then building the instrumentation funding for 2017 was a challenge, but actually, looking back, I'm just amazed at the cooperation from corporate sponsors. We had Daystar Filters donating 60 free telescopes to us, and Celestron donated 60 free mounts. MathWorks and ColorMaker were our other corporate sponsors, major corporate sponsors. And then the National Science Foundation was able to bring us from a site, looked like we were going to get about 30 sites, bring us up to the full 68 site total. So it was a challenge, but it was just a great honor to be involved with that. My favorite story is that ColorMaker, you may not have heard of them. They make food dye in Anaheim, California, but the CEO is an avid amateur astronomer, and he read about our program and sponsored 5 sites.
It's a wonderful example of public-private partnerships. Ms. Nichols-Yehling, and I know from your background with the Planetarium, you had a really important role in bringing the experience to the public. And talk a little bit about sort of outreach and the level of participation. How did you reach audiences and groups of young people not typically engaged in sort of out-of-school science activities?
So about 3 years ago, we started, as I mentioned before, working with libraries to bring telescopes to them and teach folks there how to use those telescopes, and then they were able to use them on the day of the eclipse. And we intend to keep that program going forward and even reach more libraries, other institutions, schools, and that sort of thing. We worked with other institutions, including a botanic garden, an arboretum, to teach their staff about science related to the eclipse, but try to connect the eclipse to things that would connect with their audiences, such as seeing the eclipse shadows through the leaves on trees and look at them on the ground. So,
and I'm on the education committee as well as the science committee, and I'd heard a concern that some of the schools were planning to close because they were concerned that they wouldn't be able to protect students' eyes. It seems like a sort of lost opportunity, so we need to prepare ahead for the next eclipse to make sure that this is a great, wonderful learning opportunity for students. We'll get those glasses, and I'll make sure that everybody knows, because that was a real serious concern in Oregon. And in my remaining few seconds, I'd like to, and there won't be enough time, but the follow-up on what are some of the leading theories about, one of the big outstanding questions about the sun is why the corona is so much hotter than the surface, and what are we hoping to learn, and what are these experiments conducted during 2017? How are they going to advance our understanding of the heating of the coronal area? Anybody want to,
Yeah, so the heating issue is being addressed by several of my colleagues looking at images at different temperatures, and they've had a short network of a few sites. So we hope to get a handle on that. And then the acceleration of the solar wind is another coronal problem, and the Citizen Kate data should address that.
And thank you. And as I yield back, Madam Chairman, I want to say that, Chairwoman, that in 1979, February 1979, at the time of the eclipse then, ABC News report at that time said, about the world on August 21st, 2017, may the shadow of the moon fall on a world at peace, and may we say that about 2024. And I yield back. Thank you, Madam Chairwoman.
Thank you. And I now recognize Mr. Byer for 5 minutes.
Thank you, Madam Chair, very much. I just have a series of short questions. Dr. Zurbuchen, so we call this the Great American Eclipse. What are we going to call the next one?
That's a good question. Do you have a suggestion?
No, just you have to be careful. It's like saying this is my favorite child.
Yeah, I know, yeah. I worried about it too, I don't know. I mean, I don't have a good idea at this moment.
We can have a contest.
Yeah, we should. You should, yeah.
Dr. Ulvestad, I've always been concerned. Is it just accidental? We look in the sky, and the disk of the moon looks about the same size to us as the disk of the sun. And if you look at the nice picture we have on our things, if you figure that if the moon were bigger or smaller, that eclipse wouldn't look the way it does. Is this accidental, or is there something bigger that's driving this, like?
So we live at a fortunate time in that sense, okay? The Earth is slowing down in its rotation due to the tidal forces from the moon, and as the Earth slows down, the moon moves farther away. So I was actually curious about your question myself, because the moon moves away at some centimeters per year or something like that. And I was thinking, well, when is the moon going to be too far away to not ever have a total solar eclipse again? Yeah. And it's hundreds of millions of years, so we've got some time yet.
Okay. But other than that, it's just accidental
Other than that,
they look.
I mean, if you go into the theories of anthropomorphism and why humans appeared on Earth at a certain time, you could probably come up with something, but I don't think there's any scientific reason that the moon and the sun happen to be the same angular size right now.
I think we'll recommend to our chairman and chairwoman that we have a hearing on anthropomorphism coming up. We'll invite you back. So, Dr. Penn, on the Parker Solar Probe, how long will it survive? Is it going to be going there for 2 minutes and 48 seconds?
Oh,
or?
no, I think it'll make several passes. I must admit I'm not an expert on this, but I think it'll make several orbits through the corona and gather data on both.
I think it's a 7-year mission duration, but hopefully it will survive even longer. So what's really doing is it's cranking down. So it kind of, the first time it flies by is closer to, Venus, and then kind of Mercury distance, and then really taking the periapsis, the close part of the ellipse, closer and closer until it's at 9.8 solar radii. We'll live at 215 solar radii, just for scale.
Okay, great, thank you. Dr. Hammel, I noticed, I think it was when Dr. Zurbuchen was on the airplane looking at the eclipse, he didn't have those glasses on. Do you not need the glasses when it's at totality, or?
I brought my glasses for this very purpose. Actually, once totality has been achieved, you can take off the glasses, and then you have a fantastic view. You need these glasses when any little piece of the sun is exposed. So I'm so sorry that you only saw a 99% eclipse.
It was awesome.
Yeah, but it's even awesomer if you can get into the path of totality. The difference between 99% and 100 is literally the difference between day and night. Even that tiny little piece of the sun is 1,000,000 times brighter than the corona. So once you have that last bit disappear behind the moon, everything changes. Everything changes. So I hope for 2024 you make that trek to the totality line. It's worth it.
As Mark Twain said, the difference between lightning and a lightning bug. Right?
Yeah, there you go.
Dr. Hammel, though, I'm struck with the notion that I think the testimony was we gave out 4.3 million glasses, but 51% of the Americans intended to look, which gives you 165 million. Does that mean we have 161 million people who can expect some eye damage?
No, not at all. We can share glasses. The amount of the totality, the amount that leads up to totality, when you must have these glasses, takes over an hour. It takes quite a long time. And so you put the glasses on and you see the sun sort of being chipped away by the moon. But then you take your glasses off and you hang out with your family and your friends, and a few minutes later you put them back on again. So there's a great deal of sharing that can go on. And there are many other ways to experience the eclipse, as we heard. The cereal box is a fabulous way to do it as well, and that has the advantage of teaching kids a little bit about optics too, and how a pinhole can act somewhat like a telescope. And there's a lot of other things, and all of us who were involved in outreach shared many of those other ways of enjoying the eclipse in addition to the glasses. I think that one of the lessons that we all learned from this eclipse is that we have to be even more rigorous about ensuring that there are many, many millions of glasses available in the 2024 event. I'll share my own experience. I work closely with a teacher in Virginia, and she was training 500 of her fellow teachers for that day, the day of the eclipse. And they had ordered their glasses from Amazon. And then when this came about that they couldn't be sure that their glasses were safe, she and I brainstormed on all the other ways that the teachers could experience the eclipse. I think that we will take the lesson to heart because in 2024, the eclipse is in April, and the schools will be in session. And so we want to be sure that everybody has the opportunity to experience the eclipse and can experience it safely.
I now recognize Mr. Vesey.
Thank you, Madam Chair. I wanted to ask just about the days leading up to the eclipse. I know that, like you were talking about, there was a lot of confusion about the about the glasses, and Amazon actually issued a recall on some of the glasses that were out there in the marketplace. And I just wanted to know, from you, can you talk about the efforts that your agency's made to help spread information about the glasses? Because I think when we get ready to have the next one, as far as the general public is concerned, we're here having this committee hearing today and going into, great detail about the eclipse and what it means. But in 2024, they're going to want to know about what glasses to use again. So is there any lessons, anything like that you can talk about?
So I'll say a couple words about that. So we funded the American Astronomical Society to create a web page of resources, and that web page of resources sort of had instructions on what you should do and what you shouldn't do. And well, that's fine if you know where to go to look for that web page, but I think a lesson for that is that we need to be more aggressive about marketing that kind of web page and that kind of information, and do more pushing out to the public rather than waiting for people to stumble across it because it showed up on their browser.
And we also, as a public institution, directed people to that American Astronomical Society webpage as a very trusted source of information. We also allayed people's fears because we got our glasses directly from one of the trusted manufacturers. But then for those folks who were still concerned, definitely pushing those other ways to be able to safely view the eclipse, because it wasn't necessary to actually have a pair of glasses. There were many, many other ways to do it that were still perfectly safe. So getting all those messages across through our social media, through the media, through the regular traditional media, was really important in the days and weeks leading up.
All right. What do you think just about lessons learned? I mean, you talked about what the steps that you guys took to make sure that you were getting them correctly and trying to get that information out into the public. Do you think there's something else that we can do when the next one comes around to maybe even prepare it even better?
I'd say get the word out even sooner, because it was really hectic right at the end, maybe the last 2 or 3 weeks. We were just getting phone calls and emails, people concerned every single day. But definitely working with our partners, working with the media several months ahead of time. That's one of the lessons we took from it.
Yeah. And I just want to add, I think it's absolutely important to recognize that not everybody is getting the news the same way, right? I mean, some URL somewhere may or may not be used. I mean, my children mostly, if they ever see me, it's on Instagram, which I don't know. Don't hang out there, but so basically, really looking at all the communication channels, and I think what really helped with the glasses, frankly, is people practicing up front. Basically, really looking at the glasses and measuring what they blocked, and then it was clear, hey, days ahead, right, that these particular set of glasses were not safe, and thank God for the companies really replacing them. So again, really using all communication channels that are relevant and going ahead and practicing, making sure we don't take it for granted.
Yeah. Thank you, Madam Chair.
I now recognize Mr. Foster for 5 minutes.
Thank you, Madam Chairman. First off, I myself had the pleasure of watching the eclipse with students and their families at the Joliet Library's solar eclipse viewing party in my district. And like our panelists and the members here, I was really encouraged to see people from every walk of life taking an interest in science just because of the eclipse. But I'm a scientist, so I tend to like numbers about things. And a few weeks ago, I became aware of a NASA-funded research project led by Dr. John Miller of the University of Michigan to actually quantify who viewed the eclipse, how people prepared for it, gathered information for it ahead of time, when and how they viewed it, and in the months and weeks following, how the effects that it had on their scientific engagement and literacy. So this seemed like it was precisely the sort of fact-based public engagement that NASA should be engaged in. So I was thrilled to see this report, and I would like at this point to ask unanimous consent to enter into the record a preliminary version of the report. Thank you, by Dr. John Miller, entitled Americans and Their 2017 Solar Eclipse. And so that, with that out of the way, well, one of the things I just want to mention about this is that one of the just to capture one sentence from his report, he said, during the 2 months prior to the eclipse, millions of American adults engaged in a wide array of information seeking and acquisition activities to improve their understanding of the forthcoming event. And trying to really understand that, and I understand that Dr. Miller has a very aggressive program of expanding this, is looking at things like social media, and so to actually quantify this. And I think I just want to, if any of you have any specific familiarity with that, I'd be happy to hear comments on it.
So this study was funded out of the STEM activation parts of our Science Mission Directorate. We're really excited about it. Of course, both the coverage that we managed to get all together, right? Kind of, it's not just one source. It's also, what I wanted to point out also is, of course, that a lot of the studies are still ongoing. So I'm really glad you're looking at this initial report, but we'll make sure that we draw your attention to the final report once it's being completed. I mean, I really want to make sure that we look at it just like you said. We feel it's absolutely crucial to use the tool of social sciences, to really make sure that our outreach efforts are targeted and are also up to date as things are changing as we go forward.
Well, thank you. It's always nice to see government doing its job well. Now, to get to a little bit of scientific things here, how much overlap is there between preparation and mitigation for coronal mass injection events and EMP events caused by potential nuclear attacks? Is this now a completely separate set of preparation and mitigation, or are there enough similarities about what you have to protect, even though obviously the time structure and intensity of the pulses are very different?
So I can say a few words about that, which I've fortunately learned from listening to my FEMA colleagues at the Space Weather Task Force, which is they have lots of plans on the shelf, and when they start thinking about, okay, what's going to be the result of a space weather event, then they go to their shelf and they say, here's the kind of thing we have that looks a lot like a space weather event. And so an EMP pulse that you just mentioned, I imagine, is one of the things that they would say looks kind of like a space weather event. So within at least my organization, within NSF, we don't sort of engage in that activity, but I think what they do is they sort of take as a starting point what they already have. So rather than starting from scratch, they say, okay, what's different about a solar event from another event that we've studied? And that means they're not starting from square zero.
So one of the major differences between the two events is the geographic extent of the event. And so basically, the real worry about a solar event of the type that Dr. Hammel outlined earlier is that it would be regional in nature. And so basically what would happen in an electrical system, it would overload as a regional type of thing. So far less as a local thing like lightning or even a pulse of the type that you're outlining. So there are similarities relative to the physics locally with the electric fields going up and so forth, how the systems react, but there's real differences relative to the geographic event and therefore the overall extent of the damage that could occur from it.
Right. And of course, all nuclear EMP events are not created equal, depending on altitude and related things. Well, it's nice. I just want to encourage you to actually, share your planning on that, because neither of the two events, unfortunately, are low probability events, and often dealing with low probability, high damage events is something that our democracy does not do that well. And so I'm encouraged to see that you're at least thinking about part of that problem. Well, thank you. And at that point, I'll yield back.
Thank you. And again, I thank our witnesses for just the great experience that you provided for our students and for people across the country, whether it was watching on the plane, seeing all the web activity and having that all captured, and now all the information that you have for research going forward. It was really exciting to see this all in action. I believe we only have about 9 minutes left to vote, so I do thank the witnesses, and the record will remain open for 2 weeks for additional written comments and written questions from members, and the hearing is now adjourned.